Kinetika, the new and patented technique of dynamic washing. Continuous fabric washing represents an important process both in terms of technological purposes and in the aspect of water, chemical, and energy consumption. There are different types of machines that we can call traditional, in which the fabric transits inside washing modules, or tanks placed one after the other, along a path consisting of small diameter rollers or larger diameter drums. Washing is done using the immersion technique, also adopting simple low-pressure water sprays or waterfalls, which continuously wet the fabric. To prevent wrinkling or displacement of the fabric within the washing modules, it is necessary to limit the impact force and speed with which the washing fluids interact with the fabric. Analyzing in detail the exchange phenomenon, which corresponds to the ratio of mass of washing fluid to mass of fabric to be washed, we see a low process efficiency related to the sliding and stratification of the fluid around or on the surface of the fabric. In other words, even if a high amount of recirculating or countercurrent fluid is pumped, the effective penetration and crossing, which is the basis of washing for the elimination of the products to be removed from the fabric, is limited, thus requiring the use of numerous washing tanks or modules that result in proportionate consumption. A new patented washing technique, Kinetika, is based on a revolutionary and disruptive concept that is defined as dynamic washing. The term dynamic is derived from the speed and pressure of the washing fluid. In Kinetika, there are over 700 spray nozzles mounted on perforated bars that are fed by special recirculation pumps. The pumps are capable of generating a pressure of up to 15 bar so that the jets impact the fabric at a speed of up to 32 meters per second. Why is this power used? Because washing is a process in which 4 variables are combined. See the center diagram. Time, temperature, chemistry, mechanical action. Mechanical action plays a key role in making washing deeper and more efficient. In fact, thanks to pressure and speed, it is possible to force fluid through the fabric, significantly increasing the real exchange phenomenon and thus greatly improving the washing result. To make this new technique possible, the fabric, despite the forces acting and discharging on it, must be kept in a planar shape to avoid creases, stretching, or any other deformation. For this purpose, there are 2 permeable transport belts that accompany the fabric along the washing path. The conveyor belts have an invisible joint and high water permeability that does not reduce the beneficial effect of the kinetic force of the high-pressure fluid. With this patented technique, every single drop of recirculated fluid actually interacts with the fabric by passing through it. The washing sequence. In the Kinetika module, high-pressure washing of the fabric takes place in the upper section, above the lower section consisting of the 2 fluid collection tanks. The process is divided into 3 stages that are followed in rapid sequence: washing, pre-rinse, and rinsing. The Kinetika module is in fact equipped with 3 pumps that perform as many functions. The yellow-colored pump recirculates and feeds the 10 wash bars. The purple-colored pump recirculates and feeds the 4 pre-rinse bars. The blue-colored pump is connected with the clean water pipe and feeds the last 2 rinse bars. The nozzle arrangement calls for high-pressure sprays to be arranged on both sides of the fabric. Finally, the last 4 wash bars acting alternately on the 2 opposite surfaces. The pre-rinse phase is handled by 4 bars in alternating positions on the 2 sides of the fabric. The final rinse phase with clean water is entrusted to the last 2 bars installed near the exit of the wash path, just before the fabric leaves the conveyor belts. Permeable conveyor belt. Permeable conveyor belts are essential to enable the combination of maximum washing power with maximum protection to prevent fabric problems such as creases and stretching. The two belts are made with a high permeability spiral weave structure, which leaves no marks on the fabric. It is possible to choose from a variety of weave types due to the fact that these belts are routinely used for industrial filtration processes, so there are a variety of types that are easily available and competitively priced. The two belts have a long service life, several million meters processed, and are washed continuously along with the fabric, so they do not become soiled with debris and are not subject to absorbing color or other substances discharged from washed fabrics. The transport and protective actions of the belts ensures that there are no problems with stretching, creases, abrasions, selvage curling, etc. Replacing the belts requires only a few hours of work and is a simple operation that can be performed by any trained technician. Fluid filtration. The presence of 700 spray nozzles in Kinetika washing module requires an adequate filtration system for the recirculated fluids. To prevent the nozzles from getting dirty, 3 filtration systems are provided. The first consists of 2 rotating belts that are positioned at the base of the high-pressure washing module. They intercept the passage of fluid that, by gravity, falls from the nozzles to the collection tanks below. The second consists of 2 self-cleaning motorized filters equipped with a mesh cartridge with 400-micron holes. The 2 filters are equipped with an internal rotating system with suction blades that automatically intervene in a timed manner. The third is made up of a pipe drainage system that automatically intervenes at each machine stop. A drainage device creates a vacuum effect inside the nozzle bars that removes any dirt deposit. A new concept that proposes a radical change in the principle of fabric washing. The innovations introduced by the new and patented Kinetika washing module combine in a synergy of factors. Up to 140,000 liters per hour of recirculated and filtered fluids flowing through the fabric, from the first to the last spray droplet. The kinetic force that achieves an exchange between fluid mass and fabric mass that is unparalleled. The fabric transport conditions via the 2 permeable belts that allow tension-free and crease-free processes, even on delicate fabrics. Compactness of size is not a limit for performance. Washing, pre-rinsing, and rinsing are concentrated in the dynamic washing module. Washing fluid is recirculated and filtered by a pump capable of feeding up to 100,000 liters per hour through an hydraulic circuit that feeds as many as 10 nozzle bars. Pre-rinsing uses the fluid collected in the second smaller tank located toward the outlet that is continuously fed by clean water. A dedicated pump, connected to an independent hydraulic circuit, feeds 4 nozzle bars. The last rinsing operation is done by a third independent circuit fed with clean water that is delivered by 2 nozzle bars. By means of steam heat exchangers, it is possible to heat the washing fluids independently. It is also possible to wash fabrics with superheated water at the rate of 30 meters per minute speed, which corresponds to 1,800 meters per hour. Every single meter of fabric is washed with 77 liters of fluid. In fact, dividing 140,000 liters per hour by 1,800 meters per hour yields the amazing result of 77 liters per meter. Performance comparison. Kinetika washing results were measured and evaluated through hundreds of laboratory tests using the sock slit extraction method. 3 different types of solvents were used: ethyl alcohol, petroleum ether, and acetone. By comparing the values obtained from the samples washed with Kinetika with the values obtained from the samples washed with other traditional equipment, it can be seen that the potential of Kinetika is equal to or greater than that of much more complex and larger traditional machinery. Different configurations for different results. Kinetika can be used to perform different washing processes: desizing, post-print or post-dye soaping, bleaching, deoiling, neutralization, etc. The Shrunk Processes Technical Department employs experienced process and textile chemistry technologists who are able to propose the ideal configuration and provide the after-sales technological support necessary to achieve results that guarantee quality and efficiency. Testimonials. There are now numerous customers who confirm the validity and versatility of the Kinetika project, which is adopted in the following areas: denim and cotton fabrics, cotton polyester and polyester viscose fabrics, wool, silk, cashmere, and linen fabrics for clothing and accessories, non-woven synthetic leather fabrics for car seats and upholstery, viscose fabrics and other man-made fibers for linings and sportswear. Please feel free to contact our sales partners and agents to get more information and arrange a trial with our technical team.